All right, welcome back to ABA exam review and the continuation of our BCBA practice exam series where we're going through another set of questions together and breaking them down. If you're new to the channel, welcome. If you're returning, welcome back. Please like, subscribe, and share. Check out behavioranalyst.study.com for all of our study materials, including our combo pack. When you pass your exam, let us know so we can include you in the Sunday shout out. Work hard, study hard. Let's get going. You just passed your certification exam and want to establish your own behavior analytic practice. You're developing your marketing materials with the help of your business partner and are debating over what you should write regarding treatment outcomes and treatment effectiveness. What is the most ethical way to present treatment outcomes? As analysts, no matter how effective we believe we are or we've experienced in our careers, one thing we don't want to do is guarantee outcomes because you just never know. When you're dealing with environmental variables and human variables and behavior variables, there are a lot of things that are difficult to account for. So in this case, if you want to present treatment outcomes and you're trying to develop marketing materials, what can you say about your outcomes and the efficacy of your treatment? A, provide a large time frame regarding treatment outcomes. Well, you can't do this because depending on the skill, you might be with that client for several years. So saying 6 to 12 months we can guarantee the outcomes is setting up the client for false expectations. B, provide a set time frame regarding treatment outcomes, so something concrete, 12 months. Well, that would be even worse. What if you say 8 months and you don't get there within 8 months, but you've made a lot of progress? You still set a wrong expectation. C, provide a variable time frame regarding treatment outcomes, 6 to 12 months, depending on the target skill. It's probably the best of the three, but you're still putting yourself in a position where you've got to meet just an arbitrary deadline for no real reason. What you really should do is not provide a time frame for treatment outcomes. Just explain you're going to do your best, but you can't guarantee anything when it comes to behavior. Dylan knows that he can pretend to be asleep until his parents go to bed, and then he can get up and play video games without them knowing. The only thing Dylan needs to be cautious of is the volume level of his TV at night. If Dylan is looking for the right volume level, what analysis does this resemble? So we have a situation where Dylan is looking for a amount, right? What is the right amount of volume? And he's going to use an analysis. So let's think about the different analyses we use to evaluate things like interventions. If we have a component analysis, we have different interventions that are part of a treatment package. A comparative analysis are comparing interventions that are not part of a package. And then parametric is asking how much of that intervention. So if Dylan needs to know how much volume, what analysis is he going to use? Well, he's going to use a parametric analysis. He's going to test out different volume levels until he gets it right. Think of a parametric as the dosage. How much or how little of something do we need in order to be effective? Jason introduces his intervention in the classroom setting, which is the first setting in his multiple baseline design. The intervention proves effective, so he introduces the intervention into a public setting and then finally into a home setting. If the intervention was effective in all three settings, what feature of single case design does this support? So let's think about our single case design and baseline logic. We have things like prediction, verification, and replication. With prediction, we're typically predicting what will baseline look like if intervention is not introduced. And in a multiple baseline design, what that typically looks like is something like this, where we have our different baselines. And when you introduce your intervention here, we're predicting that baseline here is going to continue. And when it does, we've verified this baseline. Now, what do we call it when we introduce an intervention here? And then we introduce the same intervention, and let's say that intervention is also effective. What have we done? Well, we've replicated the intervention. And obviously, this is a very rough drawing, but just giving you an idea of how we can look at baseline logic in a multiple baseline design. And so if Jason put the intervention in the classroom and it was effective, and then he put it in a public setting and it was also effective, what has he done? He's replicated his intervention over and over and over again. So just be aware of the three different baseline logics and how they apply to experimental designs. Withdrawal designs are typically the easiest to verify, or to think about, I should say, as far as baseline logic, multiple baseline designs can get a little more tricky. There are several fruit flies in Tim's kitchen one morning. This happens occasionally, and Tim wants to know why. Tim starts to think and believes the fruit flies typically appear only after he'd gone grocery shopping and bought fresh bananas. Tim's analysis could be described as what? So when we think about ways we describe situations, we can be descriptive, where we are just describing what happens. So in this case, Tim, being descriptive, would just say, there are several fruit flies in my kitchen. Tim is simply describing what is happening. Then we have things like prediction, where we're actually making a hypothesis about what could be causing whatever's occurring. In Tim's case, there are several fruit flies in my kitchen, and I think they appear after I've gone grocery shopping and bought fresh bananas. Now Tim is making a prediction. He's making a correlation between fruit flies and bananas. And then we have control. We're actually doing an experiment to see if our prediction is correct. Tim did not get to the experiment stage. He's still just making a prediction. He's drawing a correlation between the fruit flies and the shopping and bananas. So how would we describe Tim's analysis? Would it be descriptive? Well, no, he's taken it a step further. He's actually made a correlation between the two. So we would call it correlational. Causational would be associated with control, and as would an observation of functional control. So we are here as far as goals and behavior analysis go. Tim's analysis could be described as correlational. All right, a type 2 error is also known as what? We had a question like this earlier. Again, it's just kind of a teaching question, a definition question, just in case it comes up, right? We want to be as fluent as possible in our main task list items. Once we're fluent in those items, we want to start to expand our knowledge, because the wider net we can cast of knowledge, the better. So what is a type 2 error? Well, we know a type 1 error is a false positive. So a type 2 error is going to be a false negative. False and negative is just when data show that we had no impact or our intervention had no effect when it really did. So a type 2 error is also known as a false negative. The owner of a packaging company is told that when he is not in the office, his employees are much less productive and frequently take extended breaks throughout the day. The owner starts to be on the lookout for these behaviors while at the office, but never observes his employees engaging in extended breaks or reduced productivity. What explains this from a behavior analytic perspective? Let's think about this. We want to stay behavior analytic. When the question says you want to be behavior analytic, we're trying to use terminology from our task list or our Cooper books or our studies. In this case, we have an owner of a packaging company. When he's not in the office, his employees are less productive and take breaks. Then, when he is in the office, they are engaged and not taking breaks. They don't take breaks and they are productive when he's there. What could possibly explain that phenomenon of the behavior changing so drastically when the owner is there versus when he's not there? Well, if you look at A, the employees are experiencing reactivity. That's a great explanation for what could be occurring. When he's there, right, his employees are acting different. They're reacting to his presence. When he's gone, they're acting more like they would when he's not around. B, the initial report was wrong. That is not a very behavior analytic outlook on what is happening here, just to say the report was wrong because he observed something that someone else observed differently. C, the employees are experiencing attrition. Remember, attrition is when participants drop out of a study. Clearly not what's going on here. D, the employees are more cautious when the boss is around. That could be true, but what is more behavior analytic? To say they're more cautious or to say they're experiencing reactivity? Well, obviously A is going to be more behavior analytic, and therefore A is just going to be the better answer choice. The manager of a sporting goods store wants to better understand their busiest times of the day. The manager is going to measure how many people come into the store, and he wants to associate with 1-hour intervals from 8 a.m. to 5 p.m. What type of graph should the manager use? So let's think about this. It's worded a little strange, but let's just slow down and think about what we're trying to accomplish. What is the manager's goal? Let's ask ourselves that. He wants to understand the busiest times of the day. Immediately, you should be thinking about a certain type of graph. He wants to associate 1 hour intervals from 8 a.m. to 5 p.m. And he wants to just know, what are my busiest times of day, right? So he's going to put an X, let's say 8 a.m., 10 a.m., 12 p.m. Those are my busiest times of day. What type of graph is going to be best for drawing that association between time of day and the behavior? A line graph. Well, a line graph is good at showing different trends over time, but the better graph to use when you're associating especially time and behavior is going to be a scatter plot, because he can track as customers come in each time of day in a nice, clean format. Cumulative record, of course, is only going to track how many people total as it only goes up. And then a standard acceleration chart is not associated with this type of tracking, right? We're not using precision teaching here. We're not going to use a standard acceleration chart. The type of graph the manager wants to use is a scatter plot. Glenn observes an increase in pinching from one of his clients. He wants to get a better idea of how often it happens during a 3-hour session and wants to use rate to measure the behavior. What does Glenn need in order to calculate rate? All right, we are calculating rate, and rate is what? Rate equals frequency over time. Anytime Glenn wants to calculate rate for pinching, and he has a 3-hour session, he needs to find the frequency of pinching, and then he's going to put the time, which might be 3 hours, down here. So what does Glenn need to calculate rate? A frequency count. Yes, to calculate rate, we need frequency. B, a unit of time. Yes, down here. C, a measure of duration. No, duration is different from frequency and rate. So obviously our answer here is going to be both A and B. If to get rate, you need a frequency and a time component. You place a pickup order at your favorite sandwich shop. When you arrive, you greet the lady at the counter who tells you they are still preparing it and it should be ready in a couple of minutes. You look around and see a sign that says, "Wait here for to-go orders." So you go stand by the sign and then pick up your food. The sign is functioning as a blank relative to you standing by the sign. So we're looking at the sign here, right? We're focused on the sign in this scenario question, and we're looking at it relative to you standing by the sign. So let's find that sequence in our question. You place a pickup order, you get there, and as they are preparing it, you know that it's going to take a few minutes. So you look around and see a sign that says, "Wait here to go for to-go orders." So that sign is what we're looking at. And when you see that sign, what do? You respond. You go stand by that sign, and then you are reinforced for picking up your food. So what has the sign done? It's signaled to you that reinforcement is available for standing by the sign. That's how SDs are created. A behavior happens in the presence of a stimulus, and then a consequence happens. And as the consequence happens, it creates the SD. So the sign is functioning as what? Relative to you standing by the sign. A motivating operation. The sign is not decreasing or increasing the value of a consequence necessarily. All the sign is signaling to you is reinforcement is available if you stand by the sign. And so the sign is your SD to go stand there. It isn't a prompt because you're just looking around. You see the sign, and only when you see the sign do you go wait for the to-go order by that sign. And it isn't a consequence. The consequence is you get to pick up your food. So the sign is a SD relative to you standing by the sign. Brandon is playing with his brother when his brother starts to spin in a circle and saying, "Wheels on the bus." A few minutes later, Brandon starts spinning in a circle and singing "Wheels on the Bus" with no prompt or teaching. What explains Brandon's behavior? So we're looking at Brandon's behavior. What is Brandon doing? What do we know so far? Because it's a very vague question. Brandon's playing with his brother. His brother is spinning in a circle, singing "Wheels on a Bus." All of a sudden, Brandon does the same thing, singing "Wheels on the Bus" when spinning. Key here is, though, it happened a few minutes later. So if Brandon copied his brother, but it doesn't happen immediately, can it be imitation? It can't. Imitation happens right away. If imitation does not happen right away, it's much more likely it was observational learning. That's the big difference between imitation and observational learning. Imitation happens immediately. Had Brandon, as soon as he saw his brother start spinning, that's imitation. He didn't. What better explains Brandon's behavior is going to be A, observational learning. Thanks for watching. Be sure to check out behavioranalyststudy.com for all of our study materials. Like, subscribe, and share. We'd appreciate it. Let us know when you pass so we can include you in the Sunday shout out. Work hard, study hard. See you soon.